Good morning. I'm going to share something with all of you before I go into a few more examples of composite figures. I like to create a Jamboard so that I can display these things better for you, but I realize that some of you really like to draw all over these figures in order to figure them out. So I'm going to show you how you can clip an image and put it on a Jamboard. So the first thing I'm going to do is I'm going to open a Jamboard. So if you go to your waffle, you have to scroll down a little bit, and the one that looks like a music note is your Jamboard. So you click on that, and we are just going to zoom out, zoom in, and we are going to start a new jam, which is the plus sign down in the corner. So that will start a new jam for you. All right, so it comes up with a blank screen. As far as setting the background, you can change the background if you want. It's not necessary. And the next thing you do, you're going to find an image, okay? So what I've done is I've just searched some composite figures, and I wanted to use triangles. So I like this one right here. So I'm going to copy that image. I'm just going to place it right here. And it will go ahead and grow. I can make it big, I can make it smaller, but I can leave myself some room to go ahead and take this apart, do my figuring, label it, and whatever I need to do in order to solve this. So we're going to look at this in just a second, but I want to show you how you can snip from your work in order to paste the picture from your work onto a Jamboard. So I'm going to go on to another screen. So you just press this and it creates endless frames for your Jamboard. You just have to remember where you put things. Okay, so we are in Savas. So I have brought up a Savas page so you can see how to snip this. I want this image on my Jamboard. I don't need the words, but I want this image exactly on my Jamboard. Now I have the snipping tool on my toolbar, but most of you do not. So what you're going to type in your search bar is SNIP for snip, and you just want to open that up. A little box is going to pop up like this, snipping tool. Just click new snip. Okay, sometimes the box is right on top of what you want, but you can just move that window out of the way. So I just make sure that I get the entire image in my screen clipping, and then you have your image right here. Again, I'm going to right click and I'm going to copy that. I'm going to make sure I copied it. I can close this out as long as I still have it on my clipboard, and I don't want to save it because it's going right onto my jam. And right click. You need to control V, please. All right, and there it is right on my screen. This is the second problem I'm going to go over. You had one similar to this in your work. So I'm just going to go over very quickly how to do this. Okay, so let's go back to this first problem, and this is something that you will see again and again. They want you to find the area of the shaded part, not the entire part. So basically, I'm going to write an equation every time. So to show my thinking. So I know I need the area of the entire shape, so shaded, and I need to subtract out the area of the unshaded. Sometimes I like to do the simple part first. So I might figure out the area of the unshaded first. That's a rectangle, so it's just going to equal base times height. My base is 2 meters. My height is 7 meters. So the area, 2 times 7 is 14. 2 meters, meter times meters, meters squared. So I know I'm going to subtract out 14 meters squared. So I've got that all taken care of. It's one part of the problem. It's half of my equation. I'm feeling confident. So now I have to figure out the area of the shaded. And it looks like I have two figures there. I have this rectangle and I have a triangle. So I'm just going to label those R and T. Okay, so I know the total area of the shaded is the area of the rectangle plus the area of the triangle. So now I'm going to see what information I have and what I need. So I know for the area of a rectangle, it's going to be base times height. So do I have that base and do I have that height? Well, I can see 5 and 10. The area of the rectangle is completely labeled, so I don't have to figure anything out. I just have to multiply. So 5 times 10. Now I know the area of the triangle is half of base times height. Let me see if I have this information. Well, the base of my triangle is right here. And since I know this is a rectangle, opposite sides are congruent. So I do have the base of my triangle. So it's 1/2 base. Since opposite sides are congruent, if this is 5 meters, this is 5 meters. It's 5. Now I have to figure out the height though. So right through the center here of this triangle. All right. So I'm looking over here, I have 10. I don't have anything labeled here, but I have the entire height of this house or this figure is 16 meters. Okay. So I'm going to think like I did when I was younger. So from the bottom of the rectangle to the top is 10. So what do I need here? 10 plus what will give me 16? Well, 10 and 6 will give me a total of 16. So my height right here is 6 meters. So it's going to be 5 times 6. So 1/2 5 times 6 to right here. Okay, so now I have 50 meters squared. Half of 5 times 6. 5 times 6 is 30. 1/2 of that is 15. So my total area of the shaded is 50 meters squared plus 15 meters squared, which gives me 65 meters squared. Now I simply have to go back to my original equation here. Area of shaded minus area of unshaded, 65 meters squared minus 14 meters squared. My total area, so area total equals 51 meters squared. And that's how you solve these type of problems, okay? All right, so you probably saw one of these in your Savas work, okay? So you've got triangles and you have rectangles. You're given all your information here, but there was one thing within Savas that ended up being really confusing for a lot of you. What they had labeled were the two little triangles, the two right triangles within this larger triangle. When I told you, if I met with you in a small group, is that you don't have to break this up. You don't have to find the area of 4 triangles. So 1, 2, 3, 4. You really only have to find the area of these 2 triangles. And if it's on a rectangle like this, opposite sides, you can see the height's the same, the base is the same. These are equivalent. They're the same, they're going to be the same size. Okay? So now that I've gone through that problem, remember, sometimes information is given to you that you don't necessarily need. And it's your job as mathematicians to figure out what you need and what you don't need. Okay? So I'm going to look at this figure and I'm going to label what I have. I have a rectangle, I have a triangle here, I have a triangle there. And I'm going to write my equation. So the area total, there we go. Area total is equal to area of the triangle plus the area of another triangle. I'm putting those together for a reason, plus the area of the rectangle. So you can absolutely figure out these area of triangles like separately, but a lot of you noticed that there were 4 equivalent triangles. So you recognize the repeated addition. So repeated addition is just multiplication. So if I have 2 of the same thing, it's just like multiplying by 2. So you rewrote the equation 2 times the area of the triangle plus the area of the rectangle. And that just shortens your computation a little bit. Okay, so I know the area of the triangle is 1/2 base times height. Notice I'm putting 2 sets of parentheses because I have to figure out what's inside there first and then multiply it by 2. And I know the area of a rectangle is base times height. Let's see what information I have. I can rewrite 2 to 1/2. Now, do I have a base for my triangle? I absolutely do. It is 3 meters long. And my height is 1 meter. Now, do I have a base and height for my rectangle? I absolutely do. My base is 2 meters, and my height is 3 meters. We also talked about how multiplication is commutative. So if you look at this a different way, you do 1 times 3, you're still going to end up with 3. Same with this. If you do 3 times 2 or 2 times 3, you're still going to end up with 6. So don't be worried about the order so much because it's multiplication. Now that only works with multiplication and addition. So I have 2 times half of 3, which is going to be 1, 5. And then I have 2 times 3, which is 6. So 2 times 1.5 takes me back to 3. And that's meters squared plus 6 meters squared is going to give me 9 meters squared. So the area of the composite figure, you should put composite here. Composite is equal to 9 meters squared. Okay, remember labeling and writing out your equation is going to be very important to keep your work organized. Make sure you have all the information you need. All right, the last thing I'm going to look at today, and we talked about this. I said I was going to look at your hexagons. First of all, this is not what I needed. Oh, yes, it is. Okay, so you see there's a circle, and it is circling this hexagon right here. So when you're talking about regular, now they have to be regular hexagons, pentagons, octagons, nonagons, whatever it may be. When I talk about regular, all of the side lengths are the same, okay? That's what I mean by regular. So if this is 6, every single side length is going to be 6, okay? So it's only works with regular multi-sided polygons. Okay, there are a few measurements you have. So first of all, in green, you have the side length, okay? And then you have something called, there's a center of these shapes also, kind of like a circle. And you also have something called a radius, okay? And that comes from the center to the furthest point out. And on these hexagons, pentagons, whatever you may have, that is going to be your vertexes. So the radius is the same length from the center to each one of these vertexes. I should be doing this in blue. So you're going to have a radius here, and here, and here, and here. Once you have all your radii drawn, you should notice you have shapes. And all of these shapes are the same not equilateral, isosceles triangle. Okay, so every single shape is going to be your isosceles triangle. Okay, because you have the same side lengths here. These are all equal. And how many do we have? We have 1, 2, 3, 4, 5, 6. So there's 6 triangles. And we notice there are 6 sides. Oh, so the number of triangles you're going to have within any shape is going to be the same as the number of sides. Okay? All right. The next word I want to look at is this red. This is called the apothem. Okay, and if you notice, the apothem goes from the base of your triangle up to the center or the top. So the apothem, if you're ever given that, it's just going to be the height. And you are not going to hear that word apothem very often. You will see it referred to as height, or it'll just be labeled as in this hexagon over here. So you have all the important information that you need. You have a base, which is your side length, and you have a height, and you also have the formula for area of a triangle. Okay, so let's apply this over here. So look here, 8 inches. If I know this right here is 8 inches, I know every side is going to be 8 inches. So you can label every single side 8 inches. This is a regular hexagon. Okay? What I want to do is I want to use that as a base for my triangle. So I'm going to create my radii right here and here. And now I have a triangle. Now remember, from our other drawing, there are going to be 6 of them because we have 6 sides. So to figure out the area of this hexagon, which is truly a composite figure, so I'm going to put C. So I'm going to write in highlighter. There we go. So the area of this composite figure is equal to, and write these out separately. Triangle 1, triangle 2, triangle 3, triangle 4, triangle 5. Some of you might be frustrated right now, plus triangle 6. But I know triangle 1, 2, 3, 4, 5, and 6 are congruent. So repeated addition turns into multiplication 6 times the area of triangle 1, which is what we're going to figure out. So that's 6 times 1/2 base times height. Okay. I have my base and height, correct? We already talked about our base was 8. It's the bottom of it. My height is my apothem. That is also labeled, hallelujah, right here, 7 inches. 8 times 7. Okay, I've gone this far. Might as well finish. I've got to rewrite it somewhere. Let's take it over here. Okay, area of the composite figure is equal to 6 times 1/2 of 56. 1/2 of 56 is going to be 28. And 6 times 28, 6 times 8 is 48, 6 times 20 is 120, so it should be 168 inches squared. And that is it. We will be finishing up our Savas. Your exit ticket will be some sort of polygon. So make sure that you are drawing on it, finding your different triangles, okay, and thinking about equivalency, and just making sure that you use a calculator to back up all your answers. All right.